So, as you all heard, my name's Nick, software architect here at T-Cetra. So I've been here about 5 years. In those last 5 years, I've had the opportunity to see T-Cetra grow from a small company. We had 2 front-end web servers and a SQL database. Now we're hosted in AWS. We have hundreds of servers, 50 different services, 6 different front-end applications. And we couldn't have had that growth without growing our operation practices as well. So we've grown from having our CIO manage most of our operations. Now we have our own DevOps engineer who helps guide our developers in DevOps practices, as well as a system admin. So now, 5 years in the grand scheme of things is pretty small. So I'd like to invite someone up to the podium who knows way more about it than me, Warner Moore.
Thanks so much, Nick. Glad to be here. I'm going to be sharing the journey of infrastructure and operations over the past 20 some odd years. In a lot of different professions, we have a lot of history. If you talk to an accountant, well, they have hundreds of years of history in their profession. But when it comes to technology, we have much less history. First, I'm going to tell you a little bit more about myself. Because ultimately, you have to wonder, why am I listening to this person? Well, my name's Warner Moore, and my background is technology and information security. And I've been working with primarily high-tech companies most of my career, working with companies such as T-Checkout, Cover My Meds, and most recently, Bold Penguin. Recently, I've transitioned to starting my own business, and I'm doing strategic consulting focused on virtual chief information security officer, chief technology officer, and chief information officer roles to help companies that might not be in a position where they have a full-time person focused on that. I can help them get the strategy in place to help them improve their operations in those areas. I'm also working on building businesses, technology businesses, advising startups and stuff like that. I don't get bored very often. I'm also passionate about community. A conversation I was just having with one of you is about Toastmasters and other organizations I'm part of. I founded a local chapter of LAPSA Columbus, work with Ohio Linux Fest, DevOps Days Ohio, and founded a nonprofit organization called Tech Community Coalition almost 3 years ago. But like I said, we throw a lot of titles and terms around in infrastructure and operations. We talked about system administration. Well, even before that, we had systems programming. So today, we're going to explore that evolution. A term that's been around for a long time is system administration. It's one we all know and love. This is essentially the timeline and some of the things we're going to be exploring between system administration. Site reliability engineer was introduced after that and became a term that Google introduced, and we started to use it in the profession as well. And then web operations came around at the same time. And then finally, we're going to talk about DevOps, culture and practices, and what that means to our field now. So back in the olden days, even before system administrator, we had some titles not everyone's even heard of today. A computer operator was a term that we used to talk about mainframe programming, not even programming necessarily, where the computer operator would be a less skilled system administrator type role, but they'd be responsible for transitioning tapes. And working in an operations center, such as a network operations center, a very low-level role. Around the same time, we had a role called systems programmer, and it was more common before the proliferation of Unix and higher-level languages such as C. That came around more in the 80s. And it's traditionally someone who programs software to interface with hardware, very low-level. Early sysadmins often used machine code, such as assembly, to manage their systems. Can't find many programmers these days who work in assembly even. Only very specialized engineers quite often. And something we started to see later is we'd see systems programmer being used to refer to essentially a sysadmin, but for mainframes. You still might see that. It's super rare, but in some large corporations that have decades of history, they might still have a role that has a title of systems programmer. And there's a good chance that it has responsibility for mainframes. Then a little later, we started seeing a title called system operator. For those of us who played on bulletin board systems in the late 80s, early 90s, around the time the internet was young, but just before the internet, you might have heard the term sysop. That was often the person who ran multi-user systems. And then not so long after that, we started to have the title of system administrator. The system administrator, the wizard who calls the magic smoke. Who here knows what magic smoke means? It's an old nerd joke. No one? Not a single person? Wow. Magic smoke is the smoke that's released when a capacitor explodes, pops. So if you had an electronic board go bad, often a capacitor would pop and you'd have a little puff of smoke. So that's where magic smoke comes from. Traditionally, the system administrator is the go-to person for all of technology, the wizard who fixes the magic smoke. But really, it's the person running the systems and the networks, the servers that provide all our services. In a company like T-Cetra, the services the company runs, working with payment processing and cards for cell services, those are pretty important systems, right? The entire business runs on it. It's a lot more than running around swapping out mice and cables. These are folks who are experts in operating systems, in software, and hardware, really broad expertise. And because of the breadth of that role and the breadth of that expertise, we see that term applied to so many different roles, so many different types of organizations. And that's why we might see a sysadmin be talking about somebody who's focused on corporate IT, but just as much a sysadmin who's responsible for large-scale distributed systems, the websites that run the internet. And that's why we really see a little bit of debate. In fact, there's debates that happen now in professional organizations where people identify as system administrators about what the definition is. One universal theme, certainly during the era where sysadmin was made popular, the big thing was a lot of the work tended to be manual. Workflow that's manual, interrupt-driven, on-demand, helping people on demand, manual work, building systems and software, installing software from hand. But the thing is, that wasn't everyone. The best sysadmins tended to be just as much programmers or engineers, people who built stuff, as they were operators or people who managed software that they didn't build. The thing is, the sysadmins who were working with large-scale distributed computing systems weren't in as many markets and as many cities, not as many people had exposure to people with that skill set. So not everyone saw that aspect of sysadmins. In the, this was probably late 90s, you had a lot of Unix admins, Solaris admins, using bash or scripting languages, for loops, and SSH pipes, well later it was SSH pipes, to automate system builds. And this, in effect, was employing or applying configuration management type practices long before tools like Puppet existed. But CF Engine did exist. CF Engine's like over 25 years old now. It's been around for a minute. The thing is, though, we had folks who were using a lot of the same practices we use now and use different terms for. It was a little more sophisticated in the sense that it was fragile. Not everyone could work with it, because if somebody wasn't highly specialized in their skills, it might be difficult to sort all those scripts and the automation out. But the thing is, we were using some of the same practices we use now. But the profession has been evolving. We've been introducing new terms, new titles, and new practices. So around 2003, it took me a while to track this down. Web operations is a term I used to use back then, because I got tired of debating with people about what a sysadmin was, so I just started calling it web operations, right? At least that was distinct. And when I built this presentation, I often associated with the introduction of the term web operations with a dude called Theo from OmniTI. It was a highly skilled, well, it still exists, highly skilled boutique practice, a consulting firm, where everyone worked on large-scale distributed computing platforms. And these were folks who had network engineering skills, database administration skills, application servers. They could write the web apps themselves, of course, run the operating systems and the hardware it's on as well. Really broad skills, but deep expertise in multiple areas. And when I started looking into it for this presentation, I found that the first earliest reference I could find to web operations was in 2003. And it was buried in a Wikipedia history in a reference linking to a conference called Interop, where there was a presentation at the WebOps Summit. Really where it became more known as a term in our field is around 2008. John Allspaw and one of his colleagues at the time presented at the Velocity conference. This was back when John Allspaw was at a company called Flickr. Some of us might have heard about it. He was talking with his colleague about how automation is key, focusing more on reliability as part of the application lifecycle. Talking about 10,000, well, Amazon is 10,000, but hundreds of deploys a day. And this was in 2008 at Flickr. Now, about a year later, OmniTI, the first article I could find from them, and often what I used to send to people, it's still on the internet, it was published in 2009. So really, in the late 2000s, was where we started having a term, we started having our profession focusing and unifying around a message on what more advanced engineering practices look like as it relates to building large-scale systems. Right around the time that WebOps was originally coined, in 2003, we had Google introduce the term site reliability engineering. And the thing is, not many people knew about that. We weren't talking about SRE at the time. And the reason why we weren't is Google was pretty hush-hush about it. It was stuff they were doing internally. It wasn't necessarily top secret, but they weren't talking about it in the world or to professional organizations. They weren't sharing those practices with the world at the time. And their approach was addressing operational problems with engineering practices. In particular, they were taking software engineers specifically and having them focus on operational challenges. And these software engineers, the site reliability engineering team, was tasked with making Google's technology platform run more efficiently, run more smoothly, more reliably, more resilient systems. And really, to create large-scale, distributed systems and platforms that are reliable, automation is key. We simply can't do it without automation. In 2008, right around the time web operations was becoming more known, the term DevOps was introduced. And that was at DevOps Days in Ghent, Belgium. So we had Andrew Schaefer and Patrick Du Bois in 2008 at Agile Toronto, and they gave a talk on Agile infrastructure, really talking about some of the same things we were doing before with WebOps, and Google was doing but not talking about with SRE. In 2009 is when John Allspaw and Paul Hammond gave that presentation I mentioned at Velocity. And I misspoke earlier for someone who will call me on it later. It was 10 deploys a day. But back in 2009, that was a big deal. And this was when waterfall was super common. We might release once every 3 or 6 months. We still have organizations that do that. Now I'm used to talking about 10,000 deploys a day, or in smaller organization, deploying 10 times a week or multiple times a day. Doesn't sound like a big deal now, but it was a really big deal back then. Like I mentioned before, automation is key, and it aligns to the entire tech stack. In many cases, earlier organizations would only automate part of the technology stack. And in organizations that had been around for a while, they might have technology teams siloed, focused in different areas. That's really what DevOps was about, working together more collaboratively, and is still about. But the thing is, it was really taking some of the practices we had in place before and giving a new name for it. And it also introduced an emphasis on automating parts of the software lifecycle that weren't as commonly automated, such as automated testing with continuous integration. We automated deploys in many cases, but we'd have parts of the automation be manual steps, right? Because many of our organizations were only deploying once every 3 or 6 months, so it wasn't super automated. And ultimately, DevOps really took it to a broader conversation, where now we have many organizations aligning and working to introduce these practices who might have not been before, and using these practices to enable more frequent deployments that can be counted on. That increases speed to market. So for a company who has a lot of competitors in this space, if they can get value to the market faster, that's a competitive advantage, and that's a good way to win. And ultimately, why bother, right? Why bother with SRE where 6-month deploys? And that's exactly why to bother, to be competitive. Now so many companies are becoming more effective, having reliable technology stacks where they're introducing frequent changes. If we're not doing that, we're probably falling behind. Outages and maintenance windows have tangible business impacts. Many of our organizations, having a 4-hour maintenance window every weekend or every night, that used to be common. I laugh, one of my banking relationships, every Sunday I might be up late, 2 a.m. working. I do weird things like that, and my bank website goes down until the next Monday. Super inconvenient, but some industries still do that. Another big thing that is providing value by introducing these practices is the ability to scale up and scale down with business needs. If we're using infrastructure as a service or cloud platforms, they're pretty expensive, and we're paying for them when they're running. So if we're scaled up for a high volume of usage and not dynamically scaling down when the business needs don't need a high volume of requests to be served, well, we're spending money we don't need to spend. Another big reason to do this, it's what I want to do. It's what people leading in our professions want to do. Be able to use automation through every part of our technology stack. Be able to introduce and use modern technologies. So companies who have the best employees win, The best employees don't want to work with 3-month release cycles. If you'd like to see some examples, and I often have conversations at groups like this where somebody in the audience will be, talk about how they're a large corporation. We're a ship. We're an enterprise. We turn slow. Well, that's true, but that's often used as an excuse. Large organizations can introduce these practices. Now, it might be more difficult, not to say it can't be done. We have more and more case studies now where organizations have employed things like creating teams that aren't restricted by existing limitations in the organization. Maybe they have different tool chains or different organizational structures to empower those teams, and that can influence the practice and help them be effective. And then, as that's proven out, providing more value to the organization, that can be used to introduce to more teams. Another way, and this is not my favorite way to do it, is maybe even establish a separate division. And many research and development shops and corporations do that, where they might operate independently using more modern practices, but what they do provides value back to the organization. So if you want to see some of these examples, there's a website out there called DevOps Topologies, and it has different organizational structures and emphasizes certain anti-patterns that are good to avoid as well. Additionally, there's a website out there called High Scalability. It's one of my favorites because it has case studies of different technology organizations and how they've used different technologies to enable large-scale distributed computing platforms. So it is rainbows and unicorns, right? That's one of the things we like to talk about in some circles. If you attend DevOps days, you might be inundated with things like sparkles and rainbows. The cool thing is, there isn't one way. Some of the examples I shared might not be the right thing for your organization or other organizations out there as well. We can introduce these practices in different ways. If you want to learn more, there's a lot of great resources out there that weren't available even a few years ago. Some books that are often forgotten is The Practice of Systems and Network Administration, which is effectively the textbook or the Bible for infrastructure and operations capabilities. Tom Limoncelli wrote the follow-up book to that called The Practice of Cloud System Administration. At the time, Tom's publisher insisted that he put cloud in the title, and he has a foreword griping about it. It's pretty funny, about how he's never going to publish another book with cloud in the title. But what's really cool about that is he takes and builds on the earlier foundational practices that are still relevant, talking about some tools and practices that are commonly used in leading technology organizations now. Web Operations is a favorite book of mine. Theo of OmniTI, whom I mentioned earlier, actually has a chapter in the book. There are different people who have written chapters in the book who have case studies, such as hybrid infrastructure, where for certain load profiles, it might make sense to keep some storage on site because it's cheaper or more efficient, faster. There's all sorts of different case studies in that book that are really relevant to this day. Huge fan of it. Site reliability engineering. Google didn't used to talk about it, but they're talking about it now. I was talking with a gentleman at DevOps Days this past year because Google sponsored our event, which was pretty cool. And I was just chatting with one of the gentlemen who was manning the booth there. And I'm like, well, I'm surprised to see you here. That's really cool. And he was telling me about how Google has an initiative now to talk about the things they've been doing for a long time. Because SRE and DevOps aren't exactly the same thing, but they complement each other very well. And SRE uses a lot of DevOps practices. One of the cool things, too, is Google has published this book for free. So if you go to landing.google.com/SRE/book, you can download it for free right now. Just read it on the internet. That's super cool. Most of us know about the Phoenix project. It's a parable similar to the goal, talking about introducing process change to enable quicker speed to market through DevOps culture and practices. We also have DevOps Handbook, which is a relatively new book, which includes more case studies, also written by Gene Kim. Be active in the community. There's so many different events out there, conferences such as Velocity, DevOps Days, LISA, the Large Installation System Administration Conference. It's been around for 20 years, really smart people there. Ohio Linux Fest here in Columbus. And there's professional organizations as well, such as LOPS and Usenex. If this is your field, participate, give back. And that's it. Any questions before we wrap up? Thoughts? A lot of the challenges often tend to be on the people side, organizational challenges. The technology part's relatively easy, but we've gotten really used to organizing around teams, technology teams, and it's in effect an anti-pattern. If we have a systems team and a software team and a network team and all these different teams siloed on a role, they're often not working well together because the goals are very focused in a single technology. And one of the key tenets in DevOps is working together, right? Working together collaboratively. So organizations, and frankly, many professionals who are used to don't understand how a software engineer and a security engineer and a systems engineer can all work together towards the same goal. So I like teams with shared purpose and different roles. And one of the things we get stuck on quite often is if it's a product team, it makes sense. It's easier to understand, right? It's like, okay, we have this product, this website, this service that we're building. And of course, we can organize around that. Well, site reliability engineering is just as much a product team. SRE should have cross-functional team members as well. If you don't have representation of the different aspects of the technology field, the organization will suffer for it. Don't forget to show appreciation for your infrastructure and operational professional colleagues. We have the 20th System Administrators Appreciation Day coming up this July 26th. And at LOPS of Columbus, we throw a big party, so hope to see you there. Come check out the community here. I organize LOPS of Columbus. I also organize, I'm a founding organizer of DevOps Days Columbus. We're probably going to be in September. We'll be announcing dates soon. Organizer and on the board conference chair for Ohio Linux Fest, ohiolinux.org. Will probably be October this year. And I think that's it. Big thanks to T-Cetra for having me. Really appreciate it. Thanks for being here. Glad to be here. I have some stickers for things like DevOps Days Columbus and Ohio Linux Fest. If you want to come, hang out, get some more food, grab a sticker. Love to chat more. Thanks, everyone.